Alright, so let me solve the example 8 in the note. So if we have the set of the system of differential equation, let's write the matrix form. So x prime is equal to a will be 1, negative 1, 4, and here 3, 2, 1 from the second equation and 2, 1, negative 1 from the third equation times x. So that's the matrix form, right? Good. All right. So now what we are going to do is we want to find the eigenvalues. So we want to find a minus lambda I. So I'm going to do that very quick. A minus lambda is 1 minus lambda minus 1, 4, 3, 2 minus lambda, negative 1, 2, 1, negative 1 minus lambda. So this is a minus lambda. Now we want to find the determinant of this. So when you find the determinant here, well, we go through the, usually what I do is I use this first row, take the first element, 1 minus lambda times the determinant of this part. So 2 minus lambda, negative 1 minus lambda, here plus 1, right? Negative 1 minus 1 is plus 1. Minus by default here times the minus 1, okay, and times the determinant of the rest of the terms. Let's see, determinant of 3 times negative 1 minus lambda minus minus 2, okay, plus by default 4 times 3 times 1 is 3 minus 2 times 2 minus lambda. Okay, now this is a complicated equation. Now we want to make this equal to 0. Now we want to solve this equation to find the eigenvalues, right? Okay, let's see. It's going to be a long one, but let's do it. So here 2 minus lambda, let's try to simplify in a very general way. Here plus 3 negative 1 minus lambda plus 2 here plus 4 times 3 minus, well, I think let's multiply it out, minus 4 plus 2 lambda is equal to 0. So let's multiply everything out. 1 minus lambda, here if you multiply this out, 2 negative 2 actually, minus negative 3 lambda, okay, 2 times negative lambda, negative 2 lambda. Oops, let's do it slowly. Negative 2 lambda plus lambda minus, no, plus lambda square plus 1. Here plus negative 3 minus 3 lambda plus 2 plus here 4 times negative 1 plus 2 lambda. So I'm just simplifying. Pause it and try to do it, okay? Okay, 1 minus lambda. So here what we get is negative 1, 2 plus 1 is negative 1 minus lambda plus lambda square plus here negative 1 minus 3 lambda plus, if you expand here, negative 4 plus 8 lambda is equal to 0. Okay. So here now let's multiply these two out. Okay. I know it's going to be a long one when you're dealing with 3 by 3 matrices. So if you multiply out negative 1 minus lambda plus lambda square plus lambda square minus lambda cube minus 1 minus 3 lambda minus 4 plus 8 lambda. Finally, we can write a 1 cubic equation. Let's see. So negative lambda cube, lambda square terms here, lambda square, 2 lambda square, lambda terms, lambda, negative lambda cancelled out, negative 3 lambda, okay, or negative 3 lambda, 8 lambda is plus 5 lambda, and here negative 4, negative 1, negative 5, minus 1, negative 6 equal to 0. So this is the cubic equation. Now how do you factorize this cubic equation? Well, to factorize this cubic equation, what we can do is we can look at this part, okay, which is negative 6, and factors of negative 6 are 1, 2, 3, 6. Divide by plus or minus, okay, divide by factors of negative 1 are plus or minus negative 1. So your root should be either 1, 2, 3, 6. Usually 1 or 3 or 2 out of this, okay, since we should get distinct eigenvalues here, should be one of these threes, okay, one of these sets. Okay, so let's try it out. Let's try maybe 1. Let's try 1. Let's substitute 1 here. 1 cube is 1 plus 2 times 1 is 2 plus 5 minus 6. So let's see what we get. Here 1 plus 2 is 3. 3 minus 5 minus 6 is minus 1. 3 minus 1 is 2. 2 is not 0. So 1 is not a root. Okay, so 1 is not a root. So we have to be careful. Oh, wait a minute. I think I made a mistake. This is minus lambda q. So let's do it again. So let's substitute 1 back. So negative 1 plus 2 plus 5 minus 6. So what do we get? Negative 1 plus 2 is 1. 5 minus 6 is negative 1. Oh, we get 0. So 1 is a root. Okay, so 1 is a root. So a factor will be lambda minus 1 will be a factor. So we know that for sure. So what do we do next? Well, we divide this cubic polynomial by lambda minus 1. Minus lambda cubed plus 2 lambda square plus 5 lambda minus 6. You divide it by lambda minus 1 to find the others. Let's see. So if you divide here, you will get lambda square, negative lambda square. Negative lambda square times lambda is negative lambda cube. Here plus lambda square, now you subtract. Okay, so if you subtract, lambda cube cancel out. 2 lambda square minus lambda square is lambda square plus 5 lambda minus 6. Okay, so now here to get this one we have to multiply by lambda if you compare the first terms. So now re-multiply lambda square minus lambda. Okay, now you subtract. So 5 minus 5 lambda minus lambda is 6 lambda minus 6. Now to get here you have to multiply by 6. So here plus 6. Okay, so now you re-multiply. So 6 lambda minus 6, when you subtract, this is going to be 0. Okay, so this is the next polynomial. So we know lambda minus 1, negative lambda square plus, what was it? Lambda minus lambda plus 6, right? Plus 6, yes. Now we want to factorize this quadratic equation. Now if we factorize the quadratic equation, what we get is lambda plus 2 lambda minus 3. Try to do the factorizing by yourself. Okay, so when you factorize the cubic polynomial, this is what we get. Okay, so then the eigenvalues will be lambda is 1 is equal to 1, lambda 2 is equal to negative 2, lambda 3 is equal to 3. So these are the 3 eigenvalues. Okay, all right, I think this video is already long, so I stop from the eigenvalues here. In part 2 we will discuss how to find the eigenvectors. Okay, all right, thank you.